Students, our today's topic is logical equivalence. The two compound propositions A and compound proposition B are logically equivalent. This is a symbol for equivalence. Symbol for equivalence. We can also use this symbol for logical equivalence, that is, compound proposition A is logically equivalent to compound proposition B if A implies B is tautology. What does it mean? It means two compound propositions. If we have two compound propositions, one compound proposition is A and the other one is B, these two compound propositions will be equivalent if we take the implication of compound proposition A to be A implies B or B implies A, both are okay. You can take A implies B or B implies A. And if we prove that A implies B or B implies A is tautology, this is the condition for equivalence. If we prove that compound proposition A implies B or compound proposition B implies A is tautology, then both compound propositions will be logically equivalent. A will be equivalent to B. This is the symbol for equivalence, or we can use this symbol for equivalence. Both are used for equivalence. Compound proposition A is equivalent to compound proposition B, or compound proposition A is equivalent to compound proposition B if A implies B is tautology. This is the condition that we have to satisfy. If we are successful to prove the tautology, then both compound propositions will be logically equivalent. We consider an example. Suppose we have a compound proposition A not P or Q, and we have another compound proposition not P and not Q, and we want to show that both compound propositions, that is compound proposition A is equivalent to compound proposition B. We want to show that this compound proposition A is equivalent to compound proposition B. Then we will have to show that, we have to prove that A implies B is tautology. That is, we have to show what is A? Not P or Q. This is A. Implies what is B? This is B. Not P and not Q. So our objective is to prove that not P or Q implies not P and not Q is tautology. This is our objective. We have to show that is tautology. This is our objective. This is our objective. We have to show that this is tautology. If we are successful to prove that this compound proposition A implies compound proposition B is tautology, then both will be equivalent. Now, how we will prove that this is tautology? For this purpose, we will use the truth tables. By using the truth table, we will show that P not P or Q implies not P or Q implies not P and not Q is tautology, we will use the truth tables. Here we have two variables, so n is equal to 2. Therefore, total combinations will be 2 raised to power n, 2 raised to power 2 is equal to 4. First of all, we will take the basic variables P, Q, false, true, false, true, false, false, true, true. We will be taking 4 combinations. 4 combinations. False, true, false, true, false, false, true, true. Now, first of all, we will solve the parentheses P, R, Q. What are the rules for disjunction? False or false is false. False or true is true. True or false, true. True or true, true. The next priority will be for negation. We have 3 negations: not, P or Q, not P, not Q. So, from left to right, we will assign the priority. So, first of all, we will solve this negation, not, P or Q. Negation of false will be true, negation of true will be false, negation of true will be false, negation of true will be false. Then we will take the negation of P. This will be, negation of P will be true, true, false, false. Now we will solve not Q. Negation of false is true, negation of true is false, negation of false is true, negation of true will be false. Now, we will solve conjunction. Next priority will be given to conjunction. The conjunction is between not P and not Q. Not P and not Q. So, not P and not Q. What are the rules for conjunction? True and true. True, true and false. False, false and true. False, false and false. False. And at the end we will solve the implication. Not P or Q implies not P and not Q. So we will be using these 2 columns for implication. First value of not P or Q is true, and the first value of not P and not Q is also true. So it will become true implies true, true. The next value of P or Q is false, and the very next value of not P and not Q is also false. So it will become false implies false, true. Next value of not P or Q is false, and the value of not P and not Q is also false. So it will become false implies false, true. The last value of not P or Q is false, and the value of not P and not Q is also false. Again it will become false implies false, it will become true. So all the values are true, regardless the truth value of participating variables. It means this is tautology. So you have achieved your objective. Your objective was to prove that this is tautology. This was our objective, to prove compound proposition A implies compound proposition B is tautology. This was our objective, and we have achieved our objective. This means this compound proposition A, P or Q is equivalent to this compound proposition, not P and not Q. It means this compound proposition A is equivalent to compound proposition B. We can use another example to prove the logical equivalence. We take another example. Compound proposition A is equivalent to compound proposition B. How you will show that these two compound propositions are equivalent? How we will show that these are two compound propositions are equivalent? We will have to prove that compound proposition A implies compound proposition B is tautology. We have to prove that this is tautology. This is compound proposition A, P implies Q. This is compound proposition B, A implies B. This will be A implies B. We will have to show that this is tautology. This is our objective. This is our objective. So how we will prove that this is tautology? Now we prepare the truth table of P implies Q. All implies not Q implies not P. Here we have two variables, so the value of n will be equal to 2, and the total number of combinations will be equal to 2 raised to power 2 is equal 2 raised to power 2 equal to 4. First of all, we will take the basic variables P, Q. We will assign the truth values to this variable Q. How we will assign the truth value? First we will assign the value false to this variable Q, then true, false, and then true. We will take only 4 combinations, then false, false, true, true. Now I have applied the parenthesis on P implies Q and not Q implies not P. Why I applied the parenthesis? Basically, the parentheses have been applied to increase the priority of implication. Whenever we want to increase the priority of low precedence operator, we will use parenthesis. यानी जब भी आप लो प्रेसिडेंस ऑपरेटर की प्रायोरिटी को इंक्रीज करना चाहते हैं, आप चाहते हैं कि वो सबसे पहले सॉल्व हो, तो उसके लिए आप पैरेंथेसिस अप्लाई करेंगे। देखिए अगर हम पैरेंथेसिस अप्लाई न करते तो फिर क्या सिचुएशन बनती? सबसे पहले नॉट सॉल्व हो जाता, नॉट क्यू, फिर नॉट पी सॉल्व होता, देन हमारे पास इम्प्लीकेशंस हैं, 3 implications है, this one and this one. तो सबसे जो हाईएस्ट प्रायोरिटी होती है वो इस implication की होती है, तो P implies Q सॉल्व होगा। उसके बाद इस implication की प्रायोरिटी होगी, तो इसका मतलब क्या होगा, P implies Q की implication आप लेंगे not Q पर, तो ये स्टेटमेंट कन्वर्ट हो जाएगी किसमें, P implies Q implies not Q and then implies not P, जो कि गलत होगी, क्योंकि हमने तो क्या शो करना है, P implies Q is equivalent to not Q implies not P, तो मैंने तो implication इसके ऊपर लेनी है, इसकी implication इसके ऊपर लेनी है, यहाँ पर तो कुछ और बन गया है, टोटली कंपाउंड प्रोपोजिशन चेंज हो गई है पैरेंथेसिस अप्लाई न करने की वजह से, लिहाजा आपका जो नेट रिजल्ट होगा तो टेबल में वो गलत हो जाएगा। सो इन ऑर्डर टू इंक्रीज द प्रायोरिटी ऑफ लो प्रेसिडेंस ऑपरेटर, अब इम्प्लीकेशन की प्रायोरिटी सबसे लो होती है, बट आई वांट टू इंक्रीज द प्रायोरिटी ऑफ दिस लो प्रेसिडेंस ऑपरेटर, आई विल अप्लाई द पैरेंथेसिस। सिमिलरली इसकी प्रायोरिटी इस इम्प्लीकेशन से इस इम्प्लीकेशन की थर्ड वन की प्रायोरिटी कम है इस इम्प्लीकेशन से सेकंड वन से, लेकिन मैं इसको पहले सॉल्व करना चाहता हूं, सो आई विल अप्लाई दी पैरेंथेसिस। सबसे पहले आप इस पैरेंथेसिस को सॉल्व करेंगे, P implies Q, false implies false true, false implies true true, true implies false false, true implies true true. Then in order to solve this implication, first you will have to solve the negations, not Q and then not P, not Q, true, negation of true will be false, negation of false will be true and negation of true will be false. Similarly, in case of not P, the negation of false will be true and the negation of true will be false. Now we will take the implication of not Q over not P. True implies true, true, false implies true, true, true implies false, false, false implies false, true. And in the end you will solve this implication, P implies Q implies not Q implies not P. So we will be using these two columns. First value of P implies Q is true and the first value of not Q implies not P is also true, so it will become true implies true true. Then true implies true true. Next value of P implies Q is false and the value of not Q implies not P is also false, so it will become false implies false true and the last value is true and the last value of not Q and not P is not implies not Q implies not P is also true, so it will become true implies true true. All the values are true regardless the truth value of variables, so it means this is tautology. And this was the basic objective to prove this compound proposition as tautology. It means P implies Q is equivalent to its contrapositive not Q implies not P. P implies Q is equivalent to its contrapositive not Q implies not. So every implication is equivalent to its contrapositive.